This course is common to the A330-200 and A330-300, except for specific ATA chapters, fuel system. We will use the A330 as the generic term and occasionally refer to the two versions when appropriate. In this chapter, you will see a basic description of the A330 with all the controls in the cockpit. The A330 is the largest Airbus twin-engine aircraft in service today. It offers a choice of 3 power plants: General Electric CF6 80E1, Pratt & Whitney PW4000, Rolls-Royce RR Trent 700. With a maximum takeoff weight of 230,000 kilograms, the range of the A330-200 is 6,400 nautical miles. With a maximum takeoff weight of 217,000 kilograms, the range of the A330-300 is 4,900 nautical miles. Note: for the customized values, please refer to your airline documentation. The layout for passenger seating may change according to the operating requirements, but the cabin is equipped with a certified maximum of 375 seats for the A330-200, 440 seats for the A330-300. Between the two aircraft, the wing span has not changed, whereas the A330-200 length has decreased and its height has increased. The following areas are unpressurized: the tail cone, the main gear bay, the nose gear bay, and the radome. Let's briefly familiarize ourselves with the location of the communication antennas. VHF-1, VHF-2, VHF-3 and HF-1 and 2. Let's now have an overview of the location of the navigation antennas. Radar, localizer and glide slope, ATC-1 and 2, DME-1 and 2, GPS-1 and 2, marker, TCAS, ADF 1 and 2, radio altimeter 1 and 2, VOR. The minimum pavement width for a 180 degrees turn with symmetric thrust and no braking is 44 meters for the A330-200, 47 meters for the A330-300, based on maximum steering limit of 72 degrees. For the A330-200 and 300, if the wing clears the obstacle, the tail will also clear it. There are 3 cargo compartments: a forward cargo compartment, an aft cargo compartment, and a bulk cargo compartment. The size of the fuselage accommodates standard containers. The cockpit of the A330, a 2-man glass cockpit, is the most advanced cockpit of any civil airliner. It is designed for 2 crew members and 2 observer seats. The system controls are located on an overhead panel in such a way that both crew members can monitor them. It has an optimized layout of 6 CRT display units. The absence of control columns between the pilots and instruments ensures excellent visibility of all instruments. The pilot's seats are electrically or manually adjustable. All the seat adjustments will be presented during the simulator session. Click on the overhead panel area to display it. The overhead panel is used during the pre-flight to check that all the lights are out, dark cockpit philosophy, and in-flight to carry out emergency or abnormal procedures. The central part of the overhead panel is dedicated to aircraft systems such as air conditioning, electrical, fuel, hydraulic, and fire. Note, the most frequently used controls are located on the bottom part. For a closer look, let's select the fuel panel. On the left and right sides is the system name. For each system, there is a schematic diagram. Notice all push buttons are in the lights out configuration. Click on the forward arrow to return to the cockpit. The central part of the overhead panel is dedicated to aircraft systems such as air conditioning, electrical, fuel, hydraulic, and fire. Note, the most frequently used controls are located on the bottom part. For a closer look, let's select the fuel panel. On the left and right sides is the system name. For each system, there is a schematic diagram. Notice all push buttons are in the lights out configuration. Click on the forward arrow to return to the cockpit. Click on the glare shield area to display it. The glare shield is used by the pilots for flight guidance and short-term flight management. It is also used to control the electronic flight instruments. Click on the forward arrow to return to the cockpit. Click on the Instruments panel area to display it. The Instruments panel provides the following information to the pilots: flight information through the Electronic Flight Instrument System, EFIS, and standby instruments, system information through Electronic Centralized Aircraft Monitoring, ECAM. Click on the forward arrow to return to the cockpit. Click on the pedestal panel area to display it. The pedestal includes the controls which are usually found in conventional aircraft: radio communication, flaps, speed brakes, engine controls. It also includes the ECAM control panel, the multipurpose control display units, MCDU, which are the long-term interface with the flight management and guidance system. Click on the forward arrow to return to the cockpit. Finally, click on either side stick area to display them. The aircraft is flown manually using either side stick. They are located on the left and right sides of the cockpit.